Hi, we're going to discuss how to find difference quotient. First, we need to understand what it is. The difference quotient is basically finding the slope of a secant line that passes through the 2 points on the graph of some function f of x. This is the setup, but let me show you what we have here. So we have a point x, comma f of x. We have some step h, the increment. And then for that increment, we're getting another point whose coordinates will be x plus h, comma, f of x plus h. And basically what you're doing is you're finding the slope of the line that goes through these 2 points. And this is the equation that you always use. Do want to note that in some textbooks you may see delta x being used instead of h. So it's not going to be anything different, it's the same exact formula. So here we go. Find the difference of this. So let me write the formula here one more time. F of x plus delta h minus f of x divided by h. This is the formula we're using. That means we are going to substitute x plus h instead of x here. And it's going to be 5 times x plus h plus 4. It's the first part of the setup minus. Then it's always going to be the formula itself. And then you're going to divide it by h. And then you just need to simplify it. That gives us 5x plus 5h plus 4 minus 5x minus 4. I am of course simplifying here as well as opening parentheses. Usually students at this level of the course are familiar with this fairly simple transformation, and then we are going to see what's left in this. We have 5x and 5x cancel, 4 and 4 cancel. I do want to mention this because sometimes things are not done quite 100% correctly. When you are going to finish this part and just distribute and whatever else needs to be done, you are going to get the expression here, and when you start canceling, you are not supposed to have any terms left that do not contain h. The only terms that's supposed to be left in the numerator before you simplify it are the once you simplify it, the only terms that are going to be left in the numerator are terms containing h. None of the terms not containing h will be left there. So we're getting 5h over h, and that is giving us 5 in this case. Is the difference quotient going to give you always a number? Not really, but sometimes it does. I'll get to it. So what's going to happen here? We're going to have negative 1/2 times x plus h minus 1. This is f of x plus h minus, well, in this case it's g, but it's not going to make any difference. And here you're always going to write the function itself. And it all goes over h. So we distribute inside and open parentheses. That's going to be negative 1/2 x minus 1/2 h minus 1. And careful here, negative is going to give you plus 1/2 x plus 1 divided by h. And that takes us to what? Let's see what happens with some of the terms. Negative 1/2 x and positive 1/2 x cancel. Negative 1 and positive 1 cancel, and you're going to be left with negative 1/2 h. Negative 1/2 h divided by h is cancelled, and you're going to get negative 1/2. You may notice that in both of these problems, their answer is actually consistent with the number in front of x, and I will address that towards the end of the video. Now we had a quadratic function, so let's see how this works here. Nothing really changes, you're still doing the same thing. We are going to have f of x plus h, so it's going to be x plus h squared plus 4 minus x squared plus 4 divided by h. There's obviously more work involved because you have to expand the quadratic expression there, that binomial. So let's do it carefully. X squared plus 2xh plus h squared plus 4 minus x squared plus 4 divided by h. Moving on. So we're going to have x squared plus 2xh plus h squared plus 4 minus x squared minus 4 divided by h. Let's take a look at the terms. We have x squared and negative x squared, those cancel. We have 4 and 4, those cancel. And what I mentioned earlier is that once you simplify the numerator, the only terms that you're supposed to see there are going to be terms containing at least one h, and that's the case. So we're going to have 2xh plus h squared divided by h. We are going to factor h out in the numerator, 2x plus h divided by h, and then you cross out h, and your answer is going to be 2x plus h. So in this case it depends on the value of x. Alright, next problem. It's going to be negative 5 times x plus h squared minus 7. This is the first part. Minus, and here we just copy the function, negative 5x squared minus 7. And all that over h. So let's continue. Here we're going to get negative 5 times x squared plus 2xh plus h squared minus 7 minus negative 5x squared minus 7. Now we're ready to, well, we still need to, oh, I forgot over h. Still need to distribute the negative 5. Let's see if I can distribute that and simplify at the same time. We're going to have negative 5x squared minus 10xh minus 5h squared minus 7 plus 5x squared plus 7 all divided by h. And this will, let's see, we have some terms that can cancel. Negative 5x squared and positive 5x squared. We have negative 7 and positive 7. This is it. And the only two terms in the numerator that you have both contain h, at least one. Negative 10xh minus 5h squared divided by h. We're going to factor out h. So h, negative 10x minus 5h over h, and h's cancel, and your answer will be negative 10x minus 5h. Okay. Same thing with quadratic, but now it's a little bit more involved because you have two terms containing x, but what you do, you substitute x plus h into every one of these terms. That is going to be 3x plus h squared minus 2x plus h, and then minus the function itself. Very carefully we need to distribute this. Make sure we don't miss anything. So it's 3 times x squared plus 2xh plus h squared minus 2x minus 2h, and then minus 3x squared minus 2x all divided by h. So we're going to distribute this 3 here, and hopefully we can open the parentheses at the same time. This is 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all divided by h. Let's take a look. We have terms that are canceling. 3x squared negative 3x squared, and you have 2x and 2x, and as I mentioned before, all the terms that are remaining in the numerator contain at least one h. I'm going to factor h out to save space. The parentheses will leave us with 6x plus 3h minus 2 divided by h. You cancel this h and this h, and your answer is going to be 6x squared plus 3h minus 2. Next problem has 3 terms. I'm going to try to be very careful here. Negative x plus h squared plus 2x plus h plus 3 minus negative x squared plus 2x plus 3. I'm probably going to shift immediately down because I think I may not have enough room to expand this with all that. So we're going to get negative x squared plus 2xh plus h squared plus 2x plus 2h plus 3. That's just the first part, minus negative x squared plus 2x plus 3 divided by h. Okay, well, I mean, I do need to go down. That's a very lengthy expression. Negative x squared minus 2xh minus h squared plus 2x plus 2h plus 3 plus x squared minus 2x minus 3 divided by h. Now we finally ready to cancel. So x squared and negative x squared. We have 3 and negative 3, and we have 2x and negative 2x. I am going to save space, I'm going to factor out h right now. So it's going to be h, and that's going to leave us with negative 2x minus h, and then plus 2. And I'm going to move over here. The h is cancelled, and your answer is going to be negative 2x minus h plus 2. There's a bit of a challenge coming up. You don't see it very often, but it's a cubic one, which requires you to know how to expand a binomial with a cube. It's going to be x plus h cubed plus 2 times x plus h minus x cubed plus 2x over h. Okay, cubic expansion is the one that's going to contain 4 terms. If you don't remember how to do it, look it up. It's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed plus 2x plus 2h minus, and then we're going with x cubed plus 2x. All that is going to go over h. Yes, it looks very scary, but we're supposed to be able to simplify it afterwards. So this is x cubed plus 3x squared h plus 3x h squared plus h cubed plus 2x plus 2h minus x cubed minus 2x, all that over h. And now it's going to get much nicer because we are going to be able to get rid of a bunch of terms, x cubed and x cubed. Got 2x and 2x. Well, I wouldn't say a bunch, only these four, but all the remaining terms, please note, contain h. So we can factor out the h. In parentheses 3x squared plus 3x h plus h squared plus 2 all over h. The h is cancelled, and you are going to be left with 3x squared plus 3xh plus h squared plus 2. There's one more thing I want to show you, which is I want to generalize a couple of expressions. And remember, I showed you with two linear functions whose difference quotient we're trying to find, and I just gave you a number. So this is a linear function. Is there a general rule for that formula? Let's take a look. So it's going to be m times x plus h plus b minus mx plus b over h. Once we simplify that, it is going to be mx plus mh plus b minus mx minus b divided by h. We cross out these terms and these terms because it doesn't matter what m is, mx is going to be the same expression. They're opposites here. And then we are getting mh over h, and that's always going to give you m as your answer. So the difference quotient for a linear function is always going to be the value of the slope. What about the quadratic? So for the quadratic, it's going to be a times x plus h squared plus b times x plus h plus c divided by h. Okay, so hold on, I still need to continue. I got too excited about finishing this one and did not remember to write the second part of it. Here we go. I'm gonna move to the next line. It's kind of lengthy. A times x squared plus 2xh plus h squared plus b x plus b h plus c minus, and now we have to subtract the other part, ax squared minus bx minus c. So we basically have a quadratic expression here who's trying to generalize if there's anything common for this when you find the difference quotient. Oh, hold on, I still need to distribute one more thing. I still need to distribute that a. So it's ax squared plus 2axh plus ah squared plus bx plus bh plus c minus ax squared minus bx minus c all over h. And now ax squared is going to cancel, bx is going to cancel, and c is going to cancel. And the only terms you are going to see that are left in the numerator are the ones containing h at least once. Let me correct this so it doesn't look like b. And then we can factor out the value, well, h. We're going to have 2ax plus ah plus b divided by h, and what we are going to get here after you cross out h, it's going to be 2ax plus ah plus b. So there's more or less a general formula. Of course, it's not really worth memorizing it. It's going to come later in calculus when you learn derivatives, but for now you can still do it by hand. But this one I think is a good one for you to remember, because it will save you all this time trying to figure out those the difference quotient when it's always going to be the same as the slope of a line when you do it with the little linear function. Okay, I hope this helps.